How'd you like to listen to .NET Rocks with no ads? Easy. Become a patron. For just $5 a month, you get access to a private RSS feed where all the shows have no ads. $20 a month will get you that and a special .NET Rocks patron mug. Sign up now at patreon.netrocks.com.
Hey there. This is Jeff Fritz, the purple blazer guy from Microsoft, letting you in on a little secret about my friend Carl Franklin. You know, the guy who started .NET Rocks, the first podcast about .NET. In 2002, the guy who's been teaching Blazor on YouTube since 2020. Yeah, that Carl Franklin. Well, Carl's joined up with the folks from Code in a Castle to teach a week-long hands-on Blazor class at, are you ready? Get this, at a castle/villa in Tuscany. It's sort of a luxury vacation with Blazor learning built in. Carl's calling it the Blazor Master Class. You'll learn Blazor from the ground up, finishing the week with the ability to build and deploy Blazor applications. Since the training happens for only 4 hours in the morning over 6 days, you can bring your significant other, your partner with you, and you should, right? This part of Italy is absolutely beautiful. There's so much to see and do, and Larry and Marco from Code in a Castle are organizing daily activities both at the castle and in the area. The castle is in the Maremma, a less touristed region of Tuscany, offering both classic Tuscan hill country as well as easy access to the Etruscan Riviera with sublime local food, wine, and olive oil around every corner. Breakfast is included every day. There will be 2 communal dinners at the castle bookending the experience, and most other meals and all activities are included. And did I mention you'll learn Blazor in person from Carl Franklin? Listen, space is limited and for very good reason. This is quality training in a beautiful setting. Go to codeinacastle.com/Blazor2023. That's BLAZOR 2023 to take advantage of this amazing opportunity to join Carl in Tuscany for an unforgettable week of La Dolce Vita while advancing your programming skills in this important new technology.
After building software for a while, you know it's only a matter of time before you see an HTTP timeout or a database deadlock. In software, it's not a case of if things fail, but a case of when. One mishap like this and valuable data is lost forever. And these failures occur all the time. But it doesn't have to be this way. Introducing N-Service Bus, the ultimate tool to build robust and reliable systems that can handle failures gracefully, maintain high availability, and scale to meet growing demand. For more than 15 years, N-Service Bus has been trusted to run mission-critical systems that must not go down or lose any data ever. And now you can try it for yourself. N-Service Bus integrates seamlessly with your .NET applications and can be hosted on-premises or in the cloud. Say goodbye to lost data and system failures, and say hello to a better, more reliable way of building distributed systems. Try N-Service Bus today by heading over to go.particular.net/.NetRocks and start building better systems with asynchronous messaging using N-Service Bus.
Hey Antwerp, it's .NET Rocks! Holy crap, there must be 50,000 people here.
Yeah, who knew we were in a stadium?
I know, right? We are in a stadium. We're actually in a movie theater.
Which is cool.
It is cool. The last time we did a .NET Rocks in a movie theater, I think, was in Sofia, Bulgaria.
Oh, yeah.
Do you remember that?
Yeah, a few years ago. That was DevReach.
DevReach. And the funny thing was, the Bulgarians thought it would be funny if Richard and I announced the names of the winners, the Bulgarian winners of the swag at the end of the show. And that was funny.
For them.
For them.
Bulgarian names need to buy a vowel.
Okay. And next winner is Gzhnish Snudjnvanst. And they were just laughing their butts off. That's you?
Yeah.
Oh, you were there. Okay. All right. Well, we're glad to be here, obviously.
Yeah. Last day of the show. Fun to do a live show.
Yeah, it's
Good to
always
be in
fun
front
to
of
do
an
a live
audience.
show. We have some good stuff coming up here. Laïla Bougriâ is here, and we'll be talking to her in a minute. But first, we have to do this little thing called Better Know a Framework. Roll the crazy music.
All right, buddy. What do you got?
Well, I saw this come across Twitter. It's a tweet, and I'm linking to it.
Yeah.
Boston Dynamics. You know who those crazy people are?
There's the guys with the robots.
They make the robots that dance.
Yeah.
They do backflips now.
Yeah, a little parkour with robots and stuff.
Yeah, they used to have
It's a little uncanny.
tethered robots that were tethered, and then they got gas-powered robots. Now they're battery-driven, and they put out videos every once in a while of things that look like animals, like cougars and dogs. Well, anyway, they've put ChatGPT into a robot.
Oh, no.
And now you can talk to it, and it will talk to you back. And so there's a tweet about that. It was from April, but I thought it was so cool and a little bit scary. But they're asking it questions like, are you it's like data. Are you functioning within normal parameters? And it'll say, yes, I have this blah, 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 what my levels are, these kinds of things, my battery level. How many, what did it say? How many interactions in your last mission? And it will tell you about its last mission and where it went.
Why do they use the word mission?
I don't even know if it was mission.
Was
but
that an extermination mission?
It could have been. Yeah.
Just wondering.
It's pretty scary, but it's cool.
That's awesome.
So that's what I got.
Cool.
It's a tweet with a video.
Okay.
Yeah.
Well, the Boston Dynamics videos are always amazing.
They are fun.
Good one.
Who's talking to us, Richard?
Grabbed a comment off of show 1753. That's the one we did with Mika about Visual Studio 2022 productivity back in August last year. And Mark Wansel had this great comment. Mark has a lot of great comments, to be honest. He says, one of the things that Mika noted a few times was telemetry. I think that this would be an interesting show topic. There's a popular GitHub project called OpenTelemetry that might be a good starting space. There seems to be an art of telemetry, what to collect, how much, performance considerations, and privacy considerations. Check out opentelemetry.io. What do you think? You think we should do that? No, we're not going to do that. That's not a good idea.
No,
I don't want to do that at all.
No, we won't do that show.
Yeah. Sorry, Mark. I wish we could help you, but we can't help you.
Yeah.
But I will send you a copy of Music to Code By. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or on the Facebooks. We publish every show there. And if you comment there and I read it on the show, we'll send you a copy of Music to Code By.
And you should follow us on Twitter, but the real fun happens on Mastodon. On Mastodon, I'm at Carl Franklin at Tech Hub Social.
And I'm Rich Campbell at mastodon.social.
Send us a toot. Let us know you're listening. And that brings us to our show on OpenTelemetry.
What?
Yeah.
How did
I'm
that
sorry,
happen?
That's the topic.
I don't even know.
Laïla Bougriâ is here. She's a software engineer with over 15 years of experience in the .NET space and currently works at Particular Software where they build End Service Bus. Maybe you use it. Maybe you've heard of it.
Certainly done it on the show a few times.
Yeah. She's a Microsoft MVP and frequent speaker at conferences, and in her spare time, she loves to knit and crochet. Welcome.
Thank you.
How about Laïla, huh? We were lying when we said we weren't going to do a show about OpenTelemetry. That's kind of why we read that.
Yeah.
Yeah.
I figured if I've got a comment, literally somebody asked her for OpenTelemetry, now is the time to read it.
So, Laïla, what's the elevator pitch for OpenTelemetry?
Well, the elevator pitch. So we've had multiple telemetry signals in software for years, right? The oldest one being logs. I think we all know logs. We've also mostly used metrics. Maybe I guess distributed tracing is the newest signal. But I would say that the elevator pitch for OpenTelemetry is really correlating them all together. And that's what makes it really interesting for me, at least, because each signal has its own value, and we've also been logging for years. And even though we can see, tracing might be the better option today, but then we still have all of those logs. We don't want to go rewrite entire applications. So,
well, we do have log providers, so you can plug in however you want to do your logging, but that's not really, that's taking the same source and putting it in different places, isn't it? You're talking about ingesting different sources into one place.
Exactly. Yeah. And then being able to connect it. So basically, imagine, over the rainbow that you get an alert and there's a metric that looks out of whack. And it's like, okay, something is up. What is up? I don't know. It's just the metric is out of whack. So you have to go figure out how to do that. And that's usually a challenge because you then have to go figure out, okay, how do I connect that to those other signals that I have? But what if you could look at the metric and say, okay, I can see that it's correlated to these traces, and then go look at that. And then the traces would also be connected to the logs. And you would be able to basically, paint that entire picture of what's going on, and you wouldn't be losing all of that time doing that thing manually.
Sounds like a Wikipedia rabbit hole, right? One thing leads you to another.
So I'm trying to distinguish between all these different things. I mean, logging means a particular product like SQL Server spitting out logs about how it's functioning versus, versus metrics being more things like the state of a server, like the hard drive's pinned or are running low on memory. And then when I think about traces, I think about there's tools that specifically are about following a button click from the client to the server, to the database, and back again.
Right. Yeah, I like to think of that like following a business transaction.
Right, like the workflow.
Right. So it's true. Yeah, that's definitely true. But at the same time, we've also been logging in our applications a lot, and that still then connects together.
So this is me as a developer writing code to push messages onto a log.
Right. So that's usually, I'm a developer, right? So I'm always looking at things from the application perspective and how do I make this application observable? And there's multiple signals, and you would choose each individual signal based on whatever your scenario is. It could even be that for a specific scenario, you might come to the conclusion that using multiple signals might be useful. So, for example, let's say that a failure occurs, right? You want to keep track of that and have a trace that reflects that failure. But you might also want to have that reflected in metrics so you can do the alerting and all of that.
Yeah.
So that meaning to trip it up in through the sysadmins to say there was a failure that occurred, as well as what shows up in the log.
Right.
Now, there's a lot of third-party products out there that do telemetry. Does OpenTelemetry allow you to use those as sources and then pull them together, or does OpenTelemetry have its own things that you can plug in, or both?
It's both. And that's a good part, because I think if we look at our applications and we want to make them observable, there's a lot that we can do. But I think with the OpenTelemetry project, and also like all of the effort that the entire community has basically put into this, they've made it easy for us.
Right.
Because you could basically say, what stack am I using? Oh, I'm using ASP.NET Core, and I'm using the Azure SDK, whatever it is, right? And you could just use those instrumentation libraries that are available from those frameworks. It could be built into the framework, or it could be a dedicated package, and you can turn them on. And just by doing that, you're already collecting a bunch of information. And specifically in a distributed system, it's usually going to give you insight into that inter-service communication where we have the blind gaps.
Right.
So it already like gives you a lot of information. So the cool thing is that you can then intercept basically those traces that are being generated by those libraries. And in that would be calling activity that occurred, right? And you could create your own activities, which is by the way, the sort of same thing as a span. But yeah, they basically, what they did is the activity API already existed. And instead of creating a completely new API to match the naming of the OpenTelemetry specification, they just implemented the specification inside the activity API. So that's why the name is a little bit different. But basically what you could do is take the current activity, which could be emitted by an instrumentation library, and say, I want to add some information to this that is specific to my application, to the workflow I'm running in, so that I can get even more insight.
What's the voodoo that allows us to go between the different tiers in an app and say these are all part of the same transaction?
Right. That's basically a propagation mechanism, really, because if you think of a trace, it's basically a bunch of spans that are connected to each other. Now, what happens is at the beginning of the trace, we basically get a trace ID assigned, and that's going to be carried across all of the spans. And then each span has a unique ID. Now, in order for that information to propagate across multiple services, we need a propagation mechanism. And there's multiple protocols that are basically supported by the OpenTelemetry project. The most well-known one is a W3C trace context for HTTP headers. I always feel like I need a breath.
It rolls off the tongue, right? Like,
yeah. And then there's another one for gRPC. So it depends on what you're doing there.
So I have, for example, an Azure web app, right? I have application insights turned on. I've got all the switches lit up. And do I need OpenTelemetry at that point? What's it going to give me over what Azure Insights already has?
So the way that I look at that is what Application Insights provides you is also sort of known as black box instrumentation. So it's basically independent of your specific application code.
Yeah.
But obviously the things that we are doing in our code is usually the interesting bits. And sometimes we need a little bit more insight to understand, what pieces of code are we executing there? What are we doing? What is like the cause of latency or whatever it is? What piece is slow?
So Application Insights doesn't provide that.
Well, I think it's quite different to compare because at least to my understanding, it's more of an overall view that you get, and you can still use the Application Insights SDK directly and then still emit like application-specific telemetry, but then you're tied, right? You're tied to the vendor.
Yeah, right.
And the thing
this
is
only going to run in Azure.
Right, exactly. And if you then want to change to another vendor, you have that vendor locked in.
That's the point.
Right.
Yeah.
So if you use OpenTelemetry, then you could just wire up a different exporter.
I mean, I would also argue
terms.
that App Insights has good features for .NET specifically.
Absolutely.
Yeah.
And if you've got some other code written in other things that aren't .NET related, App Insights is only going to do so much for you.
And certainly not going to work if you're in a container on AWS, is it? No.
Yeah. So, I mean, it certainly opens the door to working with more platforms in more places.
Hence, open.
Hey, there's a concept for
Boom.
you.
Yeah, and it being available cross-platform and cross-runtime as well. Like there's implementations for instrumentation libraries in many languages for many frameworks. So that's really cool, especially if you think of like multi-stack applications.
Right.
Sure. If I've got a group of Python developers who are going to build a data importer for me, the fact that I can instrument it the same way as everything I've gotten built in .NET, that's pretty compelling.
Right.
Yeah.
And bring everything under one roof.
And measured the same way. I mean, that's the real problem, is that often we're chasing problems that transition between different systems. And because they're measured differently, it's very hard to associate that stuff together. I'm just thinking in terms of how much code I need to write as a developer to take advantage of all of this and how much of it comes out of the box.
Well, that's why I mentioned the instrumentation libraries, right? And even if you know things like event counters and stuff like that, even that has dedicated libraries available already. So you can basically just turn them on. And like I said, you could plug into that and add to that information. So usually what I say is, look at what it already gives you. Like turn on the instrumentation library
Don't
and see.
reinvent the library.
Yeah, exactly. Don't reinvent the library. So look at what's out there, turn it on and see what it emits and take a look at what type of insight that already gives you.
And it probably is picked up by OpenTelemetry just fine.
Yeah. Well, for example, let's say that you have ASP.NET Core instrumentation enabled, right? So you're going to see the request, but you don't get a lot of insight into the request. But, I mean, it has hooks that you could then plug in additional information and expose whatever is, interesting to you in that scenario. So that you could understand, like, the sort of business context of what's going on. And that's what makes it really powerful.
I spent enough time on the firefighting side of being a sysadmin, where there's stuff's being spewed out in the logs that we're looking at. We just don't know what it means.
Right.
Like anything,
it's all there.
Yeah. It's like your own little internet. Everything you need to know is there. You just can't find it.
Yeah.
So, how do you add sort of additional information that helps someone see this is where we're having the problem?
Right. That's where the vendors really come in, right? Because they are then going to offer capabilities that allow you to query, to analyze that information, and to basically get to actionable insights. Because that's the whole point of telemetry, right? That's a bunch of data, but then what do I do with it, right? So you want to basically have tools that help you get pointers on how do I fix this problem, or how do I improve this latency issue that I'm seeing, or maybe even see like which feature gets used a lot and things like that.
Which is almost more of a profiling thing, right? Like, what are the functions that are being called the most often? And we know perfectly well why the system is slow. It's the database's fault. We just blame the DBA, then we're done. Right? Life is good. All right.
Another one that I always think of is because I'm like an observability enthusiast, I would say, right? And the reason why I'm so enthusiastic about it is because, well, my sort of core focus has been message-based systems for 2 years. They're hard to troubleshoot.
Yeah, no kidding.
It's just not easy.
Asynchronous messages split across queues.
And then you get out-of-order messages, and it's like, what's going on? Yeah. Why am I seeing this fail? And especially in a message-based system, usually the problem is happening like further upstream.
Right.
So how do you get to that, right? So, and how do you connect that even outside of the messages that are being sent? Because it has to maybe connect back to, like you said, a click somewhere on a user interface. So being able to have that full visibility across all of the subsystems is really, really powerful. Yeah.
And again, I'm still worrying this is a lot of code for me to write, but you're telling me that when you're using a library that has protocol understanding, it's going to insert a lot of that information automatically for us. So it helps glue it together.
Yes, yeah. And because of the sort of nature of how distributed tracing works, that information is going to be connected together through that same trace ID that's basically being propagated.
Does this have substantial overhead? Is there any reason to only turn it on when you have a problem, or can you leave it on all the time?
Okay, that's going to be a long question to answer.
You can go for it depends.
It's an hour show.
It depends, definitely. So yeah, it definitely depends. But so usually what I tend to say is make sure that what you're collecting is useful.
Right.
Start there, because if you just turn, I don't know, every instrumentation library on the planet on, log all the things and capture all of the traces and all of that, you're going to have to sift through that, all of that information to be able to understand like what's going on. Right. So it's also not a thing of, look at all of these instrumentation libraries and then turning everything on, because you're going to be incredibly overwhelmed to the point that as a developer, you might feel like, okay, this is not useful.
Yeah.
Like, let's just turn it all back off.
I mean, I've also had the problem where I've said, okay, I'm only going to measure this thing, and then I never get data for that thing. Like, it turns out I'm looking for in the wrong place. Like, that's not a number that moves.
So some of these telemetry products that are out there have ways that they can work on a background thread, or they can attach as a sidecar into a. So do you have those kinds of things where you can sort of stay out of the way? So if there is something that takes up some more time, it can happen on a background thread?
Yeah, so that's where the OpenTelemetry project is also really interesting, because let's say that you look at the basic samples that are out there for .NET, right? What you're going to see there is that you can basically, in a service, enable OpenTelemetry, add an exporter, which means that you're collecting, let's say for the sake of the example, traces and sending them directly to a observability backend. Basically, what that could be Azure Application Insights or Jaeger or Honeycomb, whatever it is. So, but the thing is that there's many problems to that. First of all, like you said, there is overhead for that service because it has to collect all of that information. There might even be some processing behind the scenes happening as well.
If only we had a service bus.
Well, no, that's...
We'll get to that.
Yeah, we'll get to that, yeah. And then you have to export it. But then imagine that the observability backend is not available for a few seconds because it's,
that machine's
it's
rebooting.
The network.
Yeah.
It's the network.
Yeah. Who unplugged that cable? Darn it.
Right. So, well, no, usually that's handled by the libraries themselves, but it is adding that pressure to the services.
Yeah. Now you're going to get a spike of telemetry.
Right. Yeah. You don't want to have that disconnected information and then looking at half of the story.
Right.
But there are ways to solve this, and that's where the OpenTelemetry collector comes in. And then you have multiple deployment options on how to run that. The first one is, like you said, a sidecar. So basically, you're going to have a sidecar for each service that you're instrumenting, and then immediately you're offloading all of the telemetry. Yeah. Well, you're collecting it and sending it through to the sidecar, but there any processing that needs to be done, like redacting information, because remember, sensitive information, you don't want that in your in all of that telemetry you're collecting. So
Brussels is just down the road. We can be fined very easily.
I call that digital whiteout.
So then you have all of that processing, and then you could export it then to the observability backend, and you'd be able to handle all those communication issues and all of that in the sidecar, and your service is not affected. Now that's one option, but you could also set up the OpenTelemetry collector as a gateway. So it's a central component, and all of the services can basically send their telemetry information to that central component, which then will take care of processing all of that information to the backend.
I take it,
And it could batch that information, and it's a pretty powerful thing. And you could even go crazy, only if you need it, right? But you could have a sort of hybrid model in which you have a sidecar per service, which are then sending their information to the central collector as well.
Is there anything special in the storage on that? Is it just blobs or text files, or are they actually using a database on that?
Well, I think it depends on the signal.
Sure.
Because usually metrics go to time series databases, and then logs. Honestly, I don't know. It's a good question.
It depends.
But it depends.
Yeah, for sure.
Yeah.
But, actually about those time series databases, that's a sort of interesting topic on its own, because at the beginning I was talking about telemetry correlation, right? And basically adding the trace ID to the metric, which is called an exemplar in OpenTelemetry naming, so that you would be able to connect that together. So you'd see a spike in the metric and see, that's caused by those traces.
Right.
Now, the thing is that you have to be aware of what's known as cardinality explosion. So I'll try to...
Was that when a bomb goes off in the Vatican? No.
Dude.
Well, did I say that? I'm sorry. Those are cardinal explosions, not the same thing. Cardinality explosion.
Cardinality explosion.
Okay.
I'll try to explain that, but usually I do this visually, so I'll give my best try. But think of the exemplar as basically a label, right, that you're adding to a metric, and that's going to give you some insight on the context in which that metric was being collected. So let's say that I have a metric called failure rate, because I want insight into that. And to have a little bit more background information, I want to know on which environment that happened, development, tests, production, whatever it is. And I also want to know which HTTP status code came back. Now, that HTTP status code in a production environment is going to have, for the sake of the example, 30 possible values. And we have 3 different environments, so that's 3 possible values for that environment label. Now, the cardinality is basically all of the possible combinations of those values of every label that you add. That is a cardinality.
Right. So it's a multiplier.
Exactly. So we're fine with the environment and then having the HTTP status code.
Right.
And then I add customer ID.
Oh, boy. So
why would you do that?
We were 100 combinations, and then you threw in 20,000 customers and ruined everything.
Or more.
Yeah, 100,000 customers, 1 million customers.
Nobody would ever do that.
Ouch. Yeah.
And that's how we then basically get cardinality explosion, because what happens in the time series database is that every time you have a sort of unique combination, a new series is created. So your cost goes up.
Right.
And it becomes really hard to query that information. So it's also important
you just added one field. It was just one field.
One little field. If you just don't do that, there won't be this problem.
Yeah. Well, it seems like a good idea when you do it, right?
Sure. Right up until cardinality explosion.
Exactly. So it's also important to be aware of, what observability backend are you using and how does that work? Because there are some tools out there that do support high cardinality, so it's just something that you have to be aware of.
Yeah. And so you can tolerate it if you really come to the realization you have to do that. One way or the other. I mean, customer ID doesn't seem that crazy, because it is useful if we've got a customer on a phone to say, hey, I could pull all the transactions, all of those streams for all of that customer and sort of look at where they were having problems.
Yeah. That's like full production debuggability, right?
Yeah. Without a doubt. Yeah. And with that, I'm going to interrupt for one moment for this very important message.
Or two.
And we're back. It's .NET Rocks. I'm Richard Campbell. That's Carl Franklin.
Hey.
Talking to our friend Laïla about OpenTelemetry.
Hey.
And we've kind of gotten to that place now, right? Like we how do we visualize this? Because you're pulling in a lot of information. Like, are there tooling that comes with it, or do I have to write my own? What are the dashboards?
Well, that's hopefully where you choose a vendor.
Right.
And then, with the abilities of OpenTelemetry, by standardizing all of that information, I usually just say, like, try a bunch out.
Yeah.
See what are the requirements.
So there are choices.
Yeah.
I imagine you can just hook these up to standard graph controls and things like that from your various vendors if you want a dashboard.
Yeah.
Yeah.
But yeah, there's just so many options, and I feel like each of them has their own strengths. Mm-hmm. But for example, if you're running in the Azure stack, and you're already using Application Insights, it's a thing
Yeah.
and it makes sense to continue using that as well.
Yeah.
But then, for example, I've played around with Honeycomb, and I think that they're especially like the collaboration that they've built into the tool is really cool as well.
This is AWS product. No?
No, it's its own company, Honeycomb.
Oh, okay.
Big taste and a big bite.
Nice. That's the breakfast cereal, but okay.
I was a kid of the 80s.
I know what I'm thinking. I'm thinking of there is a honey something product in AWS. It's like the no code product.
Yeah.
Okay. Yeah.
Different one. But yeah, Honeycomb is an instrumentation library.
Yeah. So, and they're very invested in OpenTelemetry as well. And I think it's one of those tools that supports high cardinality. They talk about it a lot as well.
Right.
Yeah. But yeah, what stood out to me there was really the sort of collaborative features that they had, because usually if you're looking at a huge problem, you're not doing that by yourself.
Right. Yeah.
And if it's like if you have a 24/7 team and someone ends their shift, you want to be able to hand over where you left off. Things like that.
Yeah, I'm wondering about, so who is this typically the sysadmins that are going to get these packages in the first place? That's where the error messages first show up or the problems appear, and then they might be passing it to development saying, hey, we're looking at this and we think it's this kind of problem.
Well, that's where I'm also expecting some evolution. Because yes, usually now it would be a different team and they would be looking at something that looks funny.
Yeah.
Right. And then get some understanding, hopefully some actionable insights, right? And then being able to bring that back to the development team. But it's really interesting to me in the sense that we're the developers. We are the ones going to be writing that application-specific telemetry. So it's also really important to get like organization-wide alignment as well on the type of telemetry that you're going to be collecting. Yeah. So
this seems like there's an infinite number of decisions to make here, right? I mean, you just by using OpenTelemetry, that's just one step of many. What are we going to be looking at? What's the granularity of it? How are we going to query it? How are we going to look at it visually? Like, these are all things that aren't just in the box. You have to think them through.
Yeah. Well, usually what I try to advise as well is that to sort of document some guidelines, like what are you looking for with your telemetry? What are the problems that you're trying to solve? And like come up with a specific set of questions that you could, as a developer, when you write a feature, ask yourself so that you could add the telemetry that is going to answer those questions.
Right. I mean, what if you don't know what you don't know? What if you don't know what you want to look for as a guidance there?
Right.
To say,
And some of this sounds like business-related decisions. Like we sell widgets, and I want to know when a sale fails because of technology rather than the customer didn't want to buy it.
Right.
Yeah, definitely.
Or simple things like this page took too long to render or whatever. Yeah.
Yeah. And then from the sort of failure perspective, I usually try to look at the code and think to myself, if something were failing here, what would I be looking at if I were debugging this? Like, what state would be interesting to me? What variables would I be looking at? Have I captured the input enough? Have I captured what's going out to be able to understand and be able to then, go back and try to understand what happened from the outside.
Right. There's an easy solution to all of this. You just put all your code in a try with an empty catch. No problem.
Is that on error resume next?
Sort of. Yeah. It's more like /D to turn off all the debug.
I don't want to know. Just keep going.
Just don't tell me about these books.
Yeah. I mean, a lot of this we've talked about very proactively, like we're going to detect the errors before the customer does or before the customer complains.
Yeah.
I think there's another dynamic where the customer is complaining and we're getting a ticket. Now it's like, what error? I think it'd be very challenging to say, you've got this ticket, it's about this customer. It was roughly at this time, and now you want to go dig through the logs and say, can we see what this person's complaining about?
What I'd like to do is to have the customer on the phone and enable this sort of thing, but just for them, just for their customer ID, and then just watch it as they're going through the process where it fails. And now you've got something. But is that even possible?
Well, I think so, but it sort of depends on what type of sampling strategies that you're applying, and also like, the type of observability that you're collecting. Because let's say that if you want full insight, so basically any error that occurs to any user, right? Be able to say, that was, since we're in Antwerp, that was Schoss. And it was 3 p.m. on a Friday.
Right.
And basically be able to find that request and look at what were they doing. Because the thing is that users, when they open tickets or whatever it is, the thing is that they weren't paying attention to...
they were doing their usual thing.
Right.
They didn't sit down and say, let's cause an error.
I'm not thinking about every step that I did, I could be able to explain it to you later.
I usually get, it doesn't work.
Yeah.
Can you be more explicit? It doesn't work.
Right. So then being able to connect that information back and say, that was Schoss.
Right.
Yeah.
And then find that, traces, logs, metric, whatever was connected to that information. It's like being able to debug in production, really.
Yeah.
And then
But I think you just described like turning up a lot of data there too.
Yes.
Like that's also, we were also warning not to do that because you get buried in minutia.
Yep. That's where the sampling strategies come in.
Sure.
And there's different ways to go about that. So if you think about traces specifically, you basically can choose between head and tail sampling.
Right.
And head sampling, and there you're basically going to decide whether to sample the trace at the beginning. So let's say when the business transaction starts, right? You're going to immediately make the decision of, I'm keeping this or I just don't care about it.
Right.
Usually that's the most unbiased type of sampling as well.
Click place order.
Right.
Mm-hmm.
The thing is, what if something fails?
Right.
You don't know that up front. What if this request was super slow? It's not something that you can know up front. So you could be losing a lot of insightful information.
Sure.
And that's where you get, the tail-based approach, where you're basically going to collect everything. So the entire trace across all of the services that it goes through. And at the end, make the decision of, is this an interesting trace? Do I want to keep it? So, for example, does it carry some specific attributes that I care about, or was it slow?
Yeah.
And it begs the question, can you turn these things on and off in production without restarting?
Right. So that's where it becomes important again, how you deploy this, right? Because if you have a sort of direct export, then it's really tricky. But if you had it deployed as a sidecar, then it could be a thing of changing the configuration of the sidecar.
It sounds to me like
that.
Tailbase says, I'm going to assess the finished transaction. There's nothing special about this. Throw it out.
Right.
Oh, this one had an unusual value. It took too long. It generated this error and so forth. So I'm going to keep this one. And so that way you're sort of culling as you complete.
Exactly.
That's pretty cool.
Yeah. But there's a cost that comes with that.
Sure.
Because basically you're collecting everything.
Yeah, so you've got this overhead on the workload.
Yes.
Although hopefully asynchronous to some degree. Actually, that asynchronicity brings up an interesting point. Like you wanted to have the customer on the phone while you worked them through it. Like
that's one scenario.
How much latency do we have when we're doing all that processing separately? Like how soon can we see data from when a transaction actually happens?
Right. That's again another concern that you have to basically be focused on, right? Like what type of latency are you willing to accept? Right. And then it becomes a thing of being very mindful of what type of processing that you're doing there, because obviously all of that telemetry is going to have to go through that pipeline of processors. So you have to be very mindful of that. And then you have to get it out as soon as you can so that you can see it as quickly as you can and you can query it as quickly as you can.
But we're still talking seconds, aren't we? Really?
I hope even less.
Milliseconds. That's been my usual experience with asynchronous telemetry. It's only slightly behind.
Yes.
But it's not holding the transaction while it finishes. That to me, the big sin here is don't delay the customer. Get the working transaction done. All telemetry can happen later, even though that later is a few milliseconds.
Right. And that's why you offload that to another component.
Yeah, safer to work that way anyway. What you don't want is a transaction failed because you were measuring it.
Exactly. Exactly.
That's dumb.
That's a no-no.
Yeah. So definitely want to split those two things
quantum,
together.
I just got it.
Just like that, boom, it all makes sense.
It just makes sense, even though I still don't understand quantum. Yeah. I'll leave that to you and Cyprian.
Okay, well, we'll keep working on that problem.
Yeah, that's definitely something to keep in mind, is that, instrumentation is, at the end of the day, nice to have. It's not a mission critical component. So have to be very mindful of how you do that. So
what are the biggest mistakes that customers or people using the OpenTelemetry make when they first started? What's the biggest mistake?
Well, I turned everything on.
Of course you did. I do that too. I like all the knobs. Turn on all the knobs.
And then, another thing was just figuring out, what do I really need?
Right.
Yeah.
Right. So it's really understanding what your requirement is. Because if you're saying, I want to be able to debug any user request that happens in the system and have full visibility into that, as opposed to, for example, I walked into a project. It's massive. There's zero documentation. And all of the people that worked on it, they're gone.
Right. And there's no instrumentation.
Yeah. At that point, what you would like to have observability-wise is just insight into, how does this thing work?
Just follow a transaction.
Right.
Have one end-to-end trace once, and you'll have made a lot of progress.
Yes. Now, the amount of telemetry that you need for those two things is completely the opposite, right? Sure. It's like 1% versus 100. So it's definitely still, for me as well, a learning experience. Sure. I mean, this is still pretty new, and we're basically just adjusting to see still how the project is evolving.
Yeah.
Because, I mean, many parts of the specification are stable by now, but a lot of things are still evolving.
Yeah.
Another thing that keeps coming up is sort of the three pillars of observability being, traces, metrics, and logs. And I wonder, but what if a fourth one comes along? That might just happen.
I can't think of a fourth one, right?
Me neither.
We
but
define those pretty well.
Yeah. When the only thing we had was logs, could we think of metrics and traces?
I guess that's true. Yeah. We started dreaming about them. It's like I've had that experience of, I have the log from this machine, the log from this machine. Now try and line those entries up.
Would quantum computing introduce a fourth pillar?
I think it would introduce 2 to the 16th pillars, so, or 2 to the 232nd pillar. I also like this idea of knowing it failed before the customer knows it failed. Again, I'm hooked on this tail log thing of, I see these numbers as insufficient in some way. It kicks up into a system where someone can look at it and perhaps even call a customer and say, hey, we noticed. Can we help you with? It's not just you're waiting for the people to complain or for the house to be on fire.
I have never gotten a message or an email like that from a company that if that happened to me, I would be like really impressed. So I'm on a website, for example, and it screws up. And then I immediately get an email that says, hey, we noticed you had this problem.
This didn't work.
Here's a solution.
Wow. That would be amazing. The only place I ever see that is like a credit card when I'm traveling.
Yeah.
Where every so often I use the card, and a minute or so later, the phone rings and it's the credit card saying, hey, are you in Belgium?
Right.
Yep, I'm in Belgium. Okay, that's good then. Thanks. And then you're like, that's pretty cool.
Yeah.
And then it turns out that was Bob from New Jersey who
just wanted to know if I was in Belgium. That happens to me all the time.
I asked you about how service bus service buses and service bus plays into this. Obviously, this is what you do for your job. How does using a messaging system figure into OpenTelemetry?
Well, like I said earlier, right? Building a message-based system is really nice. Well, if you take into account the entire problem space. But one of the things you can go around basically is how hard it becomes to troubleshoot things in that type of system. Now, with the platform that we're building at Particular, we don't only have in Service Bus as a middleware framework, but we also have a bunch of tools. Now, Service Insight specifically is basically already that sort of black box instrumentation. It's like you don't need to do anything. You just need to configure that you want basically those platform tools to be enabled, and it already gives you insight into all of the messages that are being sent around in the system. And you can see that in a production environment and understand which exact flow and where that come from and which message led to which message. So we've really been doing observability for years.
Yeah.
That's the thing.
Well, because of the asynchronicity and out of orderness, like you can't count on timestamps. You really need to have some kind of attribute flag following between the different services to be able to know they're related.
Yeah, those are things that we capture in the message header, so we can basically know which message led to which other messages. Right. So that's really cool. But the thing that we could never solve, and that's the sort of gap that OpenTelemetry closes, is having that visibility system-wide. So connecting back to, a front end or even a database, right?
A web server that restarted in the middle of something.
Right.
Like those kinds of things. Like that's where you want the metrics to show, hey, this machine got into crisis and the supervisor killed the process and it recovered and continued, but it kicked off all this weirdness. Right, like you're looking at the trace and going, "What the heck happened here?" Right? Is the program broken? Is this a bug? And it's like, no, this is what recovery looks like.
Yeah, exactly.
Because one of these machines bailed on you.
Some of that is also built into the platform because we have insight into what are how many failures are happening. So we also have messaging specific metrics already in there, and now we're working to basically. Make sure that also connects and feeds into the OpenTelemetry signals so that if people are using it, that they get all of that information in there as well.
Yeah. Wow, that's pretty substantially cool.
Especially when you start throwing cloud in here where it's entirely possible the cloud vendor might move you and it might have impact on your software. Like stuff you literally don't have control over. Like hopefully your telemetry can surface that in a way where you're like, oh, this wasn't us. This was the vendor changed something for whatever reason, and we should absorb it, but we don't know how yet because we've never had this happen before. And now we have to look at it and say, what would we do differently?
Yeah, because we have sort of recoverability built in. So retries and all of that happens out of the box. You don't even have to configure them. But then it's like, okay, why does it take 10 times for this message to be processed every time a message of that type comes in, right? It's you don't want to hide that away. It could be that maybe there's a database suffering underneath.
Right. It retries too quickly and it takes that long for that thing to get up to speed or
that's
something along
one of the
those
side
lines.
Effects. Yeah. That's also why we have delayed retries. So we'll basically also have this sort of back off mechanism. We'll retry immediately. But if we see
back off.
Exactly.
That's a poly trick too.
Yep.
Yeah, it's the same. It's the same concept.
Yeah. So what's next for you? What are you doing next? What's in your inbox?
What's in my inbox? Well, we're still at Techorama today. Then I'm taking a few days with the family.
It's a long weekend, isn't it?
It's a long weekend.
Nice.
Yeah, it's holiday tomorrow, and then they're basically bridging to the weekend. And then on Sunday, I'm leaving to Oslo for NDC.
Very good.
Right.
I will not be joining you there this year.
So I heard.
Yeah.
Not happy to hear that.
Sorry.
Just schedules.
Yeah.
We love Oslo. We love NDC. We're there all the time usually. Gonna have to miss it this year.
Yeah.
I'm really excited to go. It's my first time at Oslo.
Oh,
so.
Congratulations. Tough show to get into.
Yeah, and I always loved the way they did the show on the floor. But I gotta tell you, this Techorama is pretty close to the awesomeness of NDC.
Yeah, a lot of fun.
And I have it home-based.
Yeah, you're at home. That's great.
It's really cool.
Everybody, give it up for Laïla Bougriâ.
And we'll see you next time on .NET Rocks!
.NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got a transmitter banned by the FCC.